on government-funded research for climate mitigation in agriculture. My name is Siobhan Kavanagh. I'm Communications Manager with the Signpost Programme and delighted to be here to facilitate this session this morning. This is a fantastic opportunity to get a great insight into the research that has happened in recent years that has provided us with some of the existing solutions to meet our climate challenges over the next couple of years, and also to get an insight into the emerging technologies that will be available to us and add to our capacity to meet our targets to 2030 and beyond. The format for this morning's session is we'll have an opening from Minister Martin Heydon first, and then we'll have three short presentations, three 10-minute presentations. We won't take questions between the presentations. We'll have a short Q&A at the end, and we'll ask Minister Heydon to close it up. So without further ado, I'll ask Minister Martin Heydon to open the session.
Thanks, Mia. Thanks very much, Siobhan. Good morning, ladies and gentlemen, both those here at the Ploughing and those online. It's a great opportunity for us to get to talk about the very important area of research and development, because it kind of underpins everything that we're talking about here at the Ploughing. Whether it's our emission targets, whether it's all of the challenges that farmers face, cost of inputs and all the rest. This is all underpinned by research that has happened in the past or research that might happen into the future. And as Minister with special responsibility for research and development in the Department of Agriculture, Food and Marine, it gives me great pleasure to open this event, which has a particular focus on the research funded by my department that will help farmers and the agriculture sector mitigate its impact on climate change. The agri-food sector has always been to the forefront of scientific research and innovation, with Ireland third in the world for agricultural research. I believe there is no better place to showcase that work than here at the Ploughing Championships. And with funding from my own department, Science Foundation Ireland, the EPA, block grants to Teagasc and the higher education institutes, agricultural research is the fourth largest sector for government support, accounting for 11% of government expenditure on research and development. And we will need all of those innovations and learnings if we are to deliver on the ambitious targets we have set ourselves. I believe we can use the technologies we have now, and we have tested and trialed. We can start on the road to delivering a 5% reduction, then a 10% reduction. And with small, steady steps, we will deliver for the sector and the rural communities. My department alone has invested over €207 million in 327 projects over the last decade. This is a significant commitment to building and maintaining research capacity and capability in the Irish agri-food sector. Given the opportunities and challenges the sector is facing over the coming decade, I believe investing in public good research will be a critical enabler in exploiting those opportunities and addressing the challenges. Many of you will be aware of our 10-year strategy for the sector, Food Vision 2030. This sets out a vision for making Ireland a world leader in sustainable food systems, and one of its 4 missions is dedicated to research, innovation, technology, and human capital. Food Vision also places emphasis on translating research findings and innovations to practical implementation on farms and in agri-food businesses. And this event today is one where we can get the results of climate change research out to farmers and the wider agricultural community sector. Because farmers are at the heart of everything that we do. And it is critical that after all the research that's done, that it disseminated down through into the grassroots, that we get that critical mass of farmers to adopt those new practices. Ireland's food produce has an international reputation that is second to none. And I believe food should be produced in parts of the world where it's most suitable. Ireland is a world leader in a grass-based production, and we will continue to produce food that is a growing world population requires. Using research and innovation, we can do that in an even more sustainable way, and I look forward to hearing more about the work on this area and contributions from the panelists here as the morning progresses. But for now, thank you very much.
Thanks very much, Minister. Our first paper this morning is by Professor Tommy Boland, who's from the School of Agriculture and Food Science at UCD. And the title of the paper is The Benefits of Multi-Species Swards on Farm.
Thanks very much, Siobhan. And I'm presenting this morning on the benefits of multi-species swards on behalf of my colleagues in UCD and in Teagasc as well. And I suppose for some people, after 25 years of research, multi-species swards have become somewhat of an overnight success. So Carl's colleagues in Johnstown Castle, John Finn and others, have a lot of work done on understanding mixtures and how to respond to drought and how to yield under cutting regimes. And then Helen Sheridan and myself in UCD have been doing work in recent years on grazing, and that work has expanded out. So our first work, we're looking at multi-species swards and sheep systems. Multi-species swards are swards or fields that contain a mixture of plants, grasses, legumes, and herbs. Traditionally, we were looking at grass-only swards, or in more recent times, grass plus legumes. But multi-species swards are more diverse and more complex mixtures. When we used multi-species swards in sheep grazing systems, we saw a lot of positive results. We reduced fertilizer requirements substantially. We were able to maintain the amount of grass we were growing despite that lower fertilizer inputs. We increased animal performance, we accelerated slaughter age, and we had positive environmental effects like increased biodiversity, increased earthworm populations, improved water infiltration, and reductions in the emissions of an important gas, nitrous oxide, one of the key greenhouse gases. As we all know here, the sheep industry is quite small. It's an important part of our agri-food sector, but it's a small part of our agri-food sector. So we moved that work out then to look at beef systems and beef animals originating in the dairy herd. With the expansion of the dairy herd, where we're seeing a big increase in the number of progeny coming from that herd entering the beef herd. And at the same time as this work was commencing, we were also seeing changes in policy, environmental legislation coming through, and increasing in input prices. So there were a number of challenges coming together, and our long-term grazing platform was, I suppose, the key project where we looked at all aspects of an animal production system, not just animal performance. And then that was funded through the Department of Agriculture, Food and the Marine in collaboration with DERA in Northern Ireland as part of the Smart Sward project. So to very briefly, I'll talk about the experiment, or one of the main experiments we ran there. We had Hereford calves from the dairy herd, male cattle. We sowed 3 different sward types. We had a perennial ryegrass only sward, which for many decades was the recommended standard. We had a perennial ryegrass and white clover sward, which in more recent times has become the recommended mixture. And we had a multi-species sward containing 2 grasses, 2 legumes, and 2 herbs. And you can see along the bottom of the slide here, the different rooting depths of those different plants. So one of the, I suppose, the reasons behind the design of that mixture is that we could use those plants to draw up moisture and potentially draw up nutrients from different parts of the sward profile. A very important point I'll draw your attention to at the moment is with the perennial ryegrass sward, we need to spread much more fertilizer nitrogen to allow that sward to grow, or to maximize the growth potential of that sward. So we're applying to 110 kilos of nitrogen per hectare per year on the perennial ryegrass sward, and the other 2 sward types receive much less fertilizer nitrogen at 90 kilograms per hectare per year. And at the moment, that's a substantial financial saving at farm level. I'm going to talk a little bit about some of the findings we've achieved from this work. If we look at the red columns here, and the red will always denote perennial ryegrass, the blue is perennial ryegrass and white clover, and the green represents the multi-species swards. When we grew a multi-species sward, per hectare, we were growing about 25% more feed, or 25% more grass dry matter to feed our animals, despite the fact that sward was receiving 60% less fertilizer nitrogen inputs. So that's both an economic saving at farm level, and it produces more feed to feed the livestock. Growing the feed is one thing. How the animals perform when they consume that feed is perhaps even more important. And we see here again, if we look at our colour scheme, the animals in green representing the multi-species sward, they grew faster than their counterparts on the perennial ryegrass sward. And interestingly, we were achieving a lot of the gains with the perennial ryegrass and white clover only sward as well. So even by adding in a single additional plant into the sward, we were improving animal performance. And this result is echoed by work from Teagasc and Athenry with sheep also. We were carrying all the animals to the same slaughter weight. So what that meant is that those faster growing animals reached their slaughter weight earlier. They were finished earlier at a younger age. And when we were bringing all those animals to the same slaughter weight, We weren't having any negative impacts on the kill-out percentage, so they yielded the same amount of meat at the end of the day. And we have some preliminary results which would show that some of the beneficial nutritional factors in the beef are increased in concentration in the animals on the multi-species sward. So that's potentially another positive outcome. You can see here from this result, we were reducing the slaughter date of those animals by approximately 1 month. And the performance of the multi-species and the perennial ryegrass and white clover were pretty much consistent with one another. The Minister has made reference to our requirement to reduce greenhouse gas emissions from our sector as well. And we can see here, when we compare our multi-species sward or our perennial ryegrass and white clover sward to our perennial ryegrass only sward, we're reducing the carbon footprint per kilogram of beef produced by 15%. The animals here in red are already about 40% lower than the national average. So there's substantial potential from multi-species swards to further reduce the greenhouse gas footprint of our beef, which is currently amongst some of the lowest figures internationally. Okay, so we're improving animal performance, we're improving sward performance, we're reducing greenhouse gas emissions and the greenhouse gas footprint. So this must be an expensive technology than one might imagine. And what we see is that we're actually increasing the net margin per hectare by almost 70% through the use of multi-species swards. Where is this financial benefit coming from? A, it's coming from the reduction in fertilizer nitrogen inputs. So we're reducing fertilizer nitrogen inputs by approximately 60%. And B, we're reducing the finishing period of those animals by 30 to 35 days. So that's reducing the indoor feeding period. That's the window during which we feed concentrates to these animals to finish them. So we've recently been funded by the Department of Agriculture, Food and Marine and DERA in Northern Ireland through the Multi for More project, which Carl's colleague in Johnstown Castle, John Finn, is leading. And while we have seen a lot of benefits to multi-species swards, there are still a lot of questions which remain to be answered. We need to look at the best mixture and optimize the mixtures that we're using. We currently have investigated a very narrow range of mixtures, even though they have performed well. We need to get better understanding of the yield, the quantity and the stability of that yield. There's much more work to be completed using gaseous emissions, so to measure methane emissions from the animals and nitrous oxide emissions from the pastures. Forage quality and weed suppression are two questions we get asked frequently. I'm quite confident at this stage that the forage quality is increased with multi-species swards from the fact that our animals are growing faster. That's the true test of forage quality. But weed suppression, weed ingress and weed control is a big issue, and it's a big issue we have seen at farm level when farmers have planted multi-species swards. And then we also need to look beyond the carbon question and look at biodiversity and soil health. As we're grappling with challenges around carbon, we're also grappling with challenges around biodiversity loss and soil health. And then there's some individual processes that can potentially feed into our national inventories around refining methane emissions and nitrous oxide emissions. So thank you very much for your attention, and I'd just like to acknowledge again the funding from the Department of Agriculture, Food and the Marine to support this research.
Tommy, thank you very much for that. And I think the results are very positive around multi-species. And I suppose coming from a KT perspective myself, there's a lot of interest amongst farmers, and that has been helped by the Department of Agriculture multi-species scheme in recent months. I think it is really important, though, that farmers are supported from an extension perspective to make sure that their experiences are equally good with it. It's one thing putting multi-species in the ground. It's another thing to make sure that it's managed correctly, that they do get the value of it. And I think that there's a big role for Teagasc and other agencies in making sure that that happens. Our second paper this morning is from Dr. Carl Richards, who's at Johnstown with Teagasc and Johnstown Castle, and it's on managing grassland nitrogen emissions.
Thank you, Siobhan, and good morning, everybody. So I'm going to talk to you this morning about some of the research we've been doing over recent years on reducing nitrogen emissions, primarily looking at reducing greenhouse gas emissions associated with nitrogen. My name is Carl Richards. I'm head of the Environment, Soils and Land Use Department in Johnstown Castle. Okay, so look, Soils are an important source of greenhouse gas emissions, primarily nitrous oxide from fertilizer use or the deposition of dung, urine from grazing animals, or manure or slurry that we apply to the soil. They're also important, I suppose, they can also lock up large amounts of carbon through carbon sequestration, but we need to better account for the emissions and the sequestration that we are having on our soils. Soil management, as I'm going to show you in the next few slides, can significantly reduce emissions, primarily associated with nitrogen. And research funded by the Department of Agriculture, either through Teagasc or through the Research Stimulus Fund, has contributed to a lot of the, I suppose, the practices and the management and the measures that I'm about to show you. And these primarily relate to reducing greenhouse gas emissions or enhancing carbon sequestration. So the work I'm going to talk to you about is from Johnstown Castle, where we have a large amount of resources, be it laboratory or physical field resources, to help us investigate these management practices. So moving into some of the research results. So fertilizer is a major source of nitrous oxide emissions. It accounts for about 30% of the agricultural greenhouse gas emissions. We had a couple of projects funded by the Department of Agriculture a number of years ago, and these focused on, one, looking at the role that fertilizer has. So you've all heard of protected urea. We did that work back in 2014, 2015. And what we showed here in the top graph was when you switch from calcium ammonium nitrate, CAN, to urea or protected urea, you reduced your emissions significantly by about 70%. And you also reduced the variability associated with those emissions. We repeated this on tillage soils, but we found no difference on those tillage soils to the effect of fertilizer formulation. And the reason for that is that those soils are generally dry, free draining soils where denitrification isn't an issue. We also found that switching to protected urea did not reduce your yields, and some recent research has shown that it can even increase yields in comparison to urea on its own. On the bottom graph, you'll see by switching from urea to protected urea, you reduce your ammonia emissions by about 70% as well. So protected urea, switching from either ammonium nitrate or urea to protected urea, reduces all the nitrogen emissions to the air by over 70%. We also looked at dung and urine, and you don't need to see the detail here. The red line on the graph indicates what the default value was in the IPCC. And generally, all the bars are significantly lower than that default value. These values are now used in the national inventory for compiling the agricultural emissions for the sector. What this led to back when we did this research, and in 2018, 2019, the EPA started to use our data in the inventory, we saw a reduction of nearly half a megaton, or 600 kilotons of greenhouse of CO2 equivalents, just by the inventory change that we saw. This didn't include any switching to protected urea, because this relates to the actual activity data on a farm. So the research that we did, funded by the department, led to a reduction in the national inventory of nearly 0.6 of a megaton, and that's significant. That's 10% of, it's a significant percentage of our national emissions, which are 60 megatons. So it's 1% of those. We're also continuing that research to look at, well, if that works with our straight nitrogen, well, what's the effect if we were to switch from ammonium nitrate or ammonium nitrate based compound fertilizers to compound fertilizers that have lower nitrate levels? So in this graph here, you can see the percentage of greenhouse gas emission reductions in comparison to CAN when we move from, so 27, 2.5, 5 on the right hand side is an ammonium nitrate based compound fertilizer. So we get dramatic reductions in emissions of over 40% when we switch to lower emitting compound fertilizers. And this research is now being expanded to look at other soil types in the north of Ireland and in the Republic of Ireland. And that's funded by the Department of Agriculture and DERA as well. And that's a current project which will lead to country-specific emission factors, which will provide us with another option for farmers to reduce emissions by changing the compound fertilizer that they use on their farm. and not just the straight nitrogen fertilizer. We've also been looking at, well, what's the effect that soil fertility has on greenhouse gas emissions? So most farmers manage their soils for optimizing agronomy, and part of that is making sure you have the right pH and the right soil phosphorus levels in your soils. But it also affects the biology of the soil, and that in itself affects the greenhouse gas emissions. This is some recent research that we've published. Again, this was part of the FACHA Irrigas funding program, where we found, where we had an unlimed soil on the left, the blue bar, that the emissions reduced from that when we increased pH. So as we increased the amount of lime that we applied to the soil, we saw a stepwise reduction in the emissions associated with that. And that emission reduction was nearly 40% by optimizing the pH from an acidic soil to a soil that is closer to a pH of 7. So at the upper end of what we'd be recommending agronomically, but it had a significant reduction in greenhouse gas emissions. So you don't need to see the detail on this, but the black lines basically show that as you increase soil pH, these are different measurements of soil biology, you change the soil biology. So you move the soil from a higher emitting soil to a lower emitting soil by basically moving or increasing certain parts of the soil microbiome there. So that's research that we've also recently published that was part of this project. And this can be included in the national inventory by integrating nutrient management planning online with the Department of Agriculture soil sampling campaign and our own soil sampling campaign and the fertilizer register, so that farmers could get credit for not just improving the soil fertility in their farm from an agronomic point of view, but also from a greenhouse gas point of view. So it's a real win-win here. We did some research then in a more recent project, again funded by the Department of Agriculture, where we looked at the effect that soil biology has. So here we looked at a long-term soil phosphorus trial, and basically what you see here is the line or the dots that are solid black are from where there was zero soil phosphorus. So we hadn't been applying phosphorus, so they were index 1 soils. And when we added carbon and nitrogen to that soil, we got a massive peak in greenhouse gas emissions. Where we didn't add carbon to it, we didn't get that same peak, and the reason for that is a soil biology effect. We then looked at in the laboratory, well, if we add nitrogen to the soil and carbon, what are the greenhouse gas emissions like? So this is for soils that are index 1, that are P0, so they've received no phosphorus, versus soils that are at index 3, so they've got 45 kilograms of phosphorus per hectare per year. And what you'll see is there was a massive reduction, like it's over 98% reduction in greenhouse gas emissions when you move from index 1, which is suboptimal, to index 3, which is the agronomic optimum for intensive grass fields. So there was a 40% reduction in emissions. Apologies. We then did a small field experiment, a short duration one, where we found something very similar. There were 2 sites with 3 levels of phosphorus on them. And you'll see across those 2 sites, as we increase soil phosphorus, we reduce greenhouse gas emissions associated with fertilizer application. And again, there's microbial effects. You don't need to see the detail here, but there was a biological effect of improving soil phosphorus. You started to increase the bacterial composition of the soil microbiome and reduce fungal activity. And this had a major effect on reducing those greenhouse gas emissions. So there's a new project that is literally just started up, which is exploring the effect of phosphorus on nitrogen cycling, but also on carbon cycling. And that's just been funded through EJP Soil, and it's working across 6 different European countries, building on the long-term phosphorus experiments that we have there to see, can we find this response across other I suppose, agricultural systems, other soil types, and other climatic zones, and also look at the effect that it has on soil phosphorus. So hopefully we'll have another win-win scenario where by optimizing soil fertility, we can both reduce greenhouse gas emissions, but enhance carbon sequestration in our soils. So in summary, the research that we've been doing over recent years has highlighted a number of management practices that farmers can carry out on their farms to reduce greenhouse gas emissions. We've also helped to refine the national inventory and make it more accurate to reflect the situations that we have on Irish farms and in Irish soils. We've also highlighted the effect that soil management has on soil biology. And it's that soil biology that is generally the engine that emits greenhouse gas emissions, but also stores carbon in our soils. And this really calls out for more work looking at the effect that soil biology has on environmental sustainability. So thank you for your attention. All of our work has been published. So if you want to hear more about it, you're welcome to contact me, and I can send you on the papers. So thank you very much.
Thank you, Carl. From again a KT perspective, the first step that we would be asking farmers to do to try and address their greenhouse gas emissions is to reduce the chemical nitrogen that they're using on the farm, and then whatever chemical nitrogen they're using is switched to protected urea. And I suppose the work that has been ongoing at Johnstown Castle for the last number of years has given us a suite of tools in that toolbox to help farmers to start making changes. And over with the projects that are ongoing at the moment, we'll provide additional solutions to us also. Our final paper this morning is from Dr. Stuart Kerwin, who's based at Teagasc Grange, and the paper is on breeding, feed additives and other GHG strategies to reduce emissions. Stuart?
Thank you, Siobhan. Good morning, everybody, and thank you, Minister, for the invitation to speak here this morning. So I'm going to, a lot of my presentation today is going to be focused around the animal and strategies with regards to breeding and feed additives. So just to give a kind of a short introduction, I'm not going to go into too much detail here, but I suppose the difference between ruminants and other animals is that they have this stomach, the rumen, that has the ability to break down cellulose. And essentially what it is a fermentation vat that's made up of a consortia of the rumen microbiome. And they break down that feed into protein and into energy that the animal can use. But one of the byproducts, another byproduct from that fermentation is methane. And I suppose that's where a lot of the why ruminants are getting that negative press. So methane, it's the second most abundant, the second most important greenhouse gas. It has a greenhouse warming potential of 28 times that of CO2 and lives in the atmosphere for about 9 to 12 years. So enteric methane production in Ireland is responsible for about 60% of our emissions, and greenhouse gas, methane emissions then from slurry, from stored farm yard manures is responsible for about 8 to 10%. And just to highlight then as well in the animal that the majority of that methane, enteric methane, comes through the breath of the animal, with about 5 to 10% excreted through the feces. So if we look at enteric methane emissions, I suppose why they're so important is that they do represent a large proportion of our greenhouse gases. So you can see there over the last 30 years that enteric methane emissions have been quite high. And I suppose if you look at 2015 and even before that, 2015, with the anticipation of the removal of milk quotas, enteric methane started to increase with the increase in dairy numbers and cattle numbers coming from the beef herd, or from the dairy herd into the beef herd. So some of the strategies that we have been looking at in Teagasc over the last couple of years, which was funded through the department and other agencies, is was breeding. So can we select animals that will produce less methane? But I suppose the crux there really was, how do we select for those particular animals? What phenotype do we go for? If we were to start looking at animals and start breeding for animals that were producing less methane on a daily basis, what we'd essentially do is just start selecting for a smaller animal, because the smaller the animal is, the smaller the stomach is, that rumen, we're going to produce less methane. So that there was the challenge. How do we select animals that will produce less methane? So one of those parameters that we looked at was residual methane emissions, and I know that probably sounds a bit technical there, but it's basically the difference between the predicted and the predicted methane emissions and what the animal actually emits on a daily basis. The reason for that is that, as I said, if we were to select on body weight or dry matter intake, all we would essentially be doing is just breeding a smaller animal. So I think this slide really will kind of highlight really where that residual methane emissions factor really plays an important role. So if you look at the top slide there, basically between the high and the low animals, what you have there is basically the same dry matter intake. If you look at the bottom graph is divided up into, again, the high emitting animals, the medium emitting animals, and the low emitting animals. And you can see there that on the first graph, which I can't see, it's the final body weight. Basically, there's no difference in performance between the high and the low emitting animals. The same then with the medium, and the same again with the low emitting animals. The same with carcass output, but daily methane emissions is the one that where they're different. But you can see there that there's a difference there between 30% between those high emitting animals and the low emitting animals. So if we start incorporating that into our breeding strategies, we can select animals that are more efficient and emit less methane. So these are just some of the publications from some of that study. It's a study that was funded from the department, Rumen Predict. We still have some ongoing work going through another project called the Master Project that is funded by the department as well, and looking further into that. I suppose the second aspect that I'm going to talk about as well is on the feed additives, and this is a project that was recently funded by the department, looking at the development and validation of novel technologies to reduce methane emissions from pasture-based agricultural systems. So I suppose the main thing that I'm going to talk about here is the feed additives. I suppose, as I mentioned there earlier on, the rumen, it's made up there of a consortium of the rumen microbiome, and they're responsible for producing that methane. So if we can incorporate, or if we can feed some sort of feed additive into the diet of the animal that can affect those bacteria that produce that methane, maybe we were successful in reducing methane. So a lot of the work we did initially was to screen a lot of these additives in the laboratory before we brought them into an animal scenario. So some of the stuff that we looked at was seaweeds. We looked at red, brown, and green seaweeds, some seaweed extracts, some byproducts from the olive feed industry, and plant and oil extracts. And then I suppose the last one there is these oxidating methane inhibitors. So just some of the in vitro, the lab-based studies that we had, you can see there that some of those methane oxidation inhibitors, or halide species, were shown great potential inside the lab, reducing methane from anywhere 60 to 67%. I suppose that the seaweed that gets a lot of press over the last couple of years is a tropical seaweed, Asparagus taxiformis. That again, we ran that through as well as a positive control, and we were getting reductions of 68%. The second seaweed there, Ascophyllum nodosum, is probably one of the most common seaweeds found off the Irish coastline. It's a brown seaweed. The bioactives in that are a lot different than what's found in the red seaweed. We were getting reductions there of 36%. And then with some of the extracts that we were able to extract from that Ascophyllum nodosum, we were getting 15% reductions in methane. So we brought these through to animal trials. We also looked at some other feed additives like aglin, miltral, some oils, the and those halide species, or another word for them is the oxidating methane inhibitors, seaweed and seaweed extracts. We've just recently conducted a trial there in Grange looking at seaweeds and seaweed extracts and oils, and we have just started a second study where we're looking at the efficacy of these oxidating methane inhibitors. Same again, I suppose we plan them whatever extracts that we find to be successful in the beef studies, we will trial them in a dairy study too. So just to go through another study as part of the Methane project is where we investigated the efficacy of 3-NOP or Bovair, which is going to be commercially known as, in growing cattle last year up until early January this year. It was just basically two treatment groups, a control group and 3-NOP. I'm not going to go through much of that. It was basically the animals were they were less than 6 months of age at the start of the trial. But I suppose the main thing out of that study is the most promising results, and these are only just preliminary results, but we were seeing somewhere between 25 and 30% reductions in methane. And there was no negative effects on intake or gain, and hoping to start the trial in Moorpark this year as well with dairy cows. So just some of the future work that we have ongoing is just to, again, just validate those oxidizing methane inhibitors. So as I said, that's currently just started there in Grange with beef cattle. We plan then to further look at rapeseed oil and rapeseed cake with beef cattle indoor as well. And I suppose one of the challenges that we have is that when we find an additive that works, is how applicable is it in an Irish context in a pasture-based system. So we are, again, as part of the Methane project, we're looking at into validation or evaluation of these slow release technologies. So some of those feed additives can be fed at pasture. And I suppose quantification, we recently got funding as well from the department for these pasture-based green feeds as well. So the work that we're doing at the moment is quantifying methane figures from our suckler herd. So in summary, I suppose some of the most promising research is their breeding. I suppose breeding is a long-term strategy. It's not a quick fix. It's still further work to be done. The feed additives, I suppose what we found is that with a lot of the feed additives is that the feed additives need to be in the room, and there has to be a constant supply there in order to have any mitigating effect on methane. So as I said, that poses that challenge. Then how do we incorporate that in a pasture-based system? And then I suppose to summarize then as well, we're further investigating those oxidizing methane inhibitors as well to see what potential they have, and then further on from that then is to develop them into slow release or encapsulation technologies. So just to finish up, I'd just like to acknowledge everybody that has worked on those projects that I have spoken about this morning from within Teagasc and ICBF and UCD as well. Thank you.
Thanks, Stuart. And I think there's some very positive signs with the feed additive work, and I suppose the challenge is the grazing system, but I'm sure there'll be technology developed for that. I'm just very conscious of time. I think we've literally 5 minutes to close this, and maybe I have time for 1 or 2 questions. Is there any questions from the audience? Okay. Heydon?
Is that on? On the feed additives, particularly 3-NOP, is that something that's available for farmers to buy currently? Or will it be available in the near future, or what's the...
It's only just been approved through the EU for use in dairy cattle. And at the moment, it's still going through that registration process for beef cattle. So I would expect that it'll be approved within the next year for beef cattle.
Right. Any other questions from the floor? Okay, I'm going to ask one quick question of the audience, or of the three panelists. The same question to the three of you. If you had a blank check in the morning of funding for additional research, where would you concentrate your funds? So that's the idea. Carl, I'll go with you first.
Is this on? I suppose, look, for me, there's two things. There's still more refinement around emission factors, particularly the animal excreta and the manure associated with grass clover and multi-species swards. But then the other is actually integrating these measures into a system and looking at the cumulative effect of them. And that system probably needs to be a low to no nitrogen future system, sort of looking post 2030. So throw all of the tools that you've heard from Tommy, what you've heard from Stuart as well, in terms of how can we actually show in the next short number of years a farm that has low to no greenhouse gas emissions and offsets those emissions with carbon sinks.
Very good. Stuart?
Yeah, I suppose kind of just to add to what Carl said there as well, I suppose just on the additives, really, like a lot of the work that we have done is kind of short-term studies. So I think a lot of funding needs to be put in there to longer-term trials to see that basically that the efficacy of those additives are sustained, because at the moment we're only doing trials for a couple of months and we're seeing it, and you know that rumen microbiome has a unique ability to adapt and change inside. So I think we really need to do longer studies really there.
Okay, good point. And Tommy?
Yeah, I think we can all probably talk about our own specific research areas, and we all need more funding in our own specific research areas. But in terms of three areas, I think at a national level we need to invest in, it's people, you know, training people to conduct research and putting a pathway in place to retain those highly skilled professionals in our research and development industry at a national level, whether that's within Teagasc or the university sector, wherever. The equipment and the infrastructure. We have to go faster and further now than we ever had to do before, and we need infrastructure to do that. And this infrastructure, it's expensive, but it's essential. And then the third point I would say there, Siobhan, is getting the research results implemented at farm level in the knowledge transfer space, and for us as researchers to produce the tool that will allow the knowledge transfer specialists to transfer that information and to support the farmers in taking up, because we can have all the technologies in the world, but if not being implemented at farm level, we're not making gains. And I would make one final quick comment just to wrap up. We must remember in all of this conversation about emissions, our primary output at farm level is food and food products that are very highly desired internationally, and we need to protect that as well.
Okay, good point. Frank, do you want to make a comment?
Comment, and Tommy has kind of made it for me anyway. I was just going to say, after the minister gives each of the three people the three checks, I hope there's one left in the checkbook for the advisory work that needs to go on with this. So my question kind of was to each of the panelists, and look, very quick answer me. You know, what do you see as the biggest challenge, I suppose, to getting this research actually used out with farmers?
Very quick answer now, because we literally have 2 minutes.
I think the people engaged in knowledge transfer could probably answer that better than I can. I think farmers need to see a benefit of it, Frank, that there's, you know, if we can get a win-win in terms of economic benefit and environmental benefits, I think that'll be a big gain. It's one thing seeing it working in a research centre, but getting it out onto farms, and you know, with the signpost farms and other initiatives like that, where farmers can see it being successful on a farm that they can identify with, because most farmers don't identify with Moore Park or with Johnstown Castle or with UCD. They have this very erroneous impression that we've endless resources and endless budget to make these things happen. So I think if they can see it working in a real farm, it's much more likely to be taken up on their individual farms.
Yeah. Okay, I think we might leave it at that. I just want to thank the panel. So Tommy, Stuart and Carl, thank you very much for your presentations. Yes, and I'm going to ask the Minister just to close the meeting. Thank you very much.
Thanks very much, Siobhan, and thanks everybody both here and online. Particularly huge thanks to Tommy, Stuart and Carl, and acknowledge the presence here of Frank Kamara, Director of Teagasc. As a government minister, at any time when somebody starts talking about blank checks, I get very nervous, but a week before budget, it's enough to keep me awake at night. But there's a number of takeaways that I get from the presentations of the panel here this morning. And, you know, whether it's Tommy regarding the multi-species swards, Carl about managing the farmland nitrogen, or Stuart about the ruminants. The thing that strikes me is the amount of work that has gone into this. The comment about being an overnight success after 25 years, Tommy, struck me. Carl, you referenced, working on this project, protected urea, which is all in fashion now. But, back to 2014, 2015, that goes to show that the work of researchers and how long it takes, and how important the work that we're doing now and the investment we're making in research now will be into the future. So it just reinforces to me that research is an ongoing, evolving situation that we need to keep investing in, and that's why my Department of Agriculture have put such key investment into that area. And we do acknowledge the role of not just the researchers, but also then disseminating that information out. Because if you look at our climate emission targets at 25%, which we all agree are challenging and ambitious, it'll only be achieved by a critical mass of farmers, coming together and adopting those measures. And the one thing I know about farmers is they're completely, hugely influenced by what their neighbours are doing and what their neighbours think of how they farm. So the more farmers to start doing the practice, then how that takes the fear out of it for other farmers to adopt a new practice and to make a change, which isn't always easy to do. But the other big takeaway I have from this panel discussion this morning is one of great hope and optimism, because there are solutions there. And, I've made this point on numerous occasions. When we talk about that 25% target, we don't, a lot of the focus in the media and among farmers here this week is about how do we get from the 18% beyond the Teagasc MAC curve to 25%. But we can't skip over the bits of the 5 to 10%, the 10 to 15%, and make sure that we adopt those practices that we do know works now. And what we have built in there with an achievable target is that time and space to allow the research to work. Yes, we have to invest heavily and make sure that as that information comes to pass, that we get that out and adopted by a critical mass of farmers. But it's being able to do that in a way that I think we have bought that time for us. And what's critical is that we don't let the foot up on the stuff we know that works, that we need to get more farmers adopting at the same time. And that's the balance of government. And we will continue to invest very heavily in research in all its guises. Over the last 12 months, I've visited research institutions throughout the country where projects funded by my department are taking place, and I've been struck by the level of knowledge and expertise that exists, in particular, the large number of highly motivated postgraduate and postdoctoral researchers that are striving to find answers to many of the complex challenges facing us, none more so than in the area of climate change. We need to get the message out there to farmers and drive uptake of these new technologies and farm practices. This will need to be underpinned by strong government supports and a professional knowledge transfer system, which I believe we have both in Teagasc and in our private agricultural advisors. So, there is great hope here. There is lots of opportunity for optimism. And for the non-farming community who are dialing into this, who might have a certain set attitude in terms of the role we're playing, I hope you get a sense of the science and the innovation that there is behind our food production system. A food production system that I am really, really proud of, and that we as a country should be so proud of. Tommy touched on it at the end. Never let's forget what we're trying to protect here. We're trying to protect an economic activity in rural Ireland that is crucial to our overall economy, but it also produces some of the best top quality, nutrient-dense food that is needed now and will be needed for long into the future as well. So I'd like to thank everybody here in the panel and for everyone who participated and followed it today, and we'll talk to you soon. Thanks very much.